The deep sea is a peculiar wonderland of underwater worlds that the ocean holds in secret. At mid-ocean ridges, towering hydrothermal vents pump superheated mineral-rich fluids out into the water, supporting a collection of curious creatures. Meanwhile, swarming the sunken carcasses of whales are communities of scavengers converging to feed on the decaying carrion. But perhaps even stranger than these two unexpected ecosystems are the brine pools, vast accumulations of saline-saturated water that display as surreal deep-water lakes resting on the ocean floor, and seem to defy the laws of physics. Though unexplained and alluring, these are highly toxic death traps for many creatures. On the one hand, the pools themselves create undersea dead zones on the ocean floor. And yet on the other, they provide the basis for life through chemosynthesis, supporting vibrant gardens of life. Two distinct worlds, existing side by side at the bottom of the endless blue. Brine pools are a hauntingly beautiful landscape. The Gulf of Mexico contains a large number of these lakes, varying in size from 1 meter across to up to 20 kilometers long. And their origins can be explained by the processes of salt tectonics. During the Jurassic period, the Gulf was a shallow sea that became closed off from the rest of the ocean by the surrounding land. Over time, the sea evaporated, leaving behind a layer of salts and minerals. Layers of sediment buried the salt bed over time, protecting the minerals from being dissolved when the Gulf later rejoined the world ocean. Under the weight of sediment and water, the salt bed deformed and shifted. Cracks in the sediment above allowed water to creep down to the ancient salt deposits, dissolving the salt into a concentrated brine. Along with trapped gases, the brine was forced out of the sea floor by warping and cracking of the salt plates. Highly salty water seeped up into the ocean, where its density far exceeded that of the water that surrounded it. This difference in density allowed the brine to flow across the sea floor landscape, where it pooled into basins, forming expansive lakes. At certain points along their length, the brine overflows and trickles down like a waterfall. This is the outflow, which maintains the level of the pool while it's replenished continually from the salt beds below. But the landscape here is characterized also by a series of strange ridges, slopes, and valleys, caused by salt tectonics and mineral deposition sculpting the overlying landscape. This encased the brine pools in mineral dams of their own creation, and laid the foundations needed for the birth of a whole new ecosystem. Brine pools create two distinct environments that exist side by side in equilibrium on the sea floor. Within, the brine itself is toxic to most organisms, for it contains almost no oxygen and is far too salty to support life. In addition, the dense layer of brine harbours toxic chemicals such as hydrogen sulfide and methane. When an organism enters a brine pool, they attempt to breathe the hypersaline environment, which in many cases brings on toxic shock. Those who delve below the surface never return, and they become pickled, their bodies preserved in perpetuity within the brine for centuries without decay, like these crabs, which may have lost their footing while searching for prey along the shores. The grey crust that seems to cover the insides of the pools and the bodies within are crystals of barium sulfate that precipitate out of the brine. The deadly nature of these pools has earned them a number of titles. They are often dubbed pits of despair and hot tubs of death, and it's easy to see why. But despite this, around their perimeter, these death traps create biological hotspots on the sea floor. There is a fine border between where life seems altogether absent and where it's able to thrive in great abundance. Tiny amphipods dwell atop a mineral-rich, biologically diverse sea floor. Vast colonies of tube worms stretch beyond the dim horizon, while the shores are fringed with dense mats of giant mussels. Life is found in such high abundance here for a number of reasons. The ridges and valleys surrounding the pools provide a hard substrate for sessile organisms, like tube worms, crinoids, and anemones to attach to. In contrast, out on the soft muds that comprise much of the abyssal plain, these organisms cannot settle. In addition, brine pools are regions of high primary productivity. Food is scarce in the deep sea. The lack of sunlight means there are no photosynthesizers like plants or phytoplankton to generate energy and form the base of a food web. So instead, many creatures of the deep are drawn to chemosynthetic oases like hydrothermal vents and brine pools, where they rely on energy derived not from the sun, but from chemicals. At these pools, it's the presence of the toxic dissolved gases that support a unique food web. These chemicals, though deadly to the animals themselves, are converted into food by specialized bacteria through the process of chemosynthesis. This forms the foundation of the ecosystem, as the bacteria here occupy the role of producers held by phytoplankton in the sunlit surface waters. Thus, a community of uniquely specialized organisms thrives on the borders of a toxic dead zone. An entire ecological system has developed, with inhabitants interacting through symbiosis, predation, and fierce competition for space and nutrients. The mussels depend on these chemosynthetic bacteria living within their gills for survival, and together they form a mutualistic relationship. In return for supplying the energy needed to sustain themselves and the mussels, the bacteria are protected from being predated by grazers that stalk the shores of the lakes. In their large numbers, these bivalve aggregations create a rocky beach for the pools, partaking in a commensal relationship with snails, shrimp, and squat lobsters that use the mussels for shelter or trail across their shells in search of the bacteria. Larger predators also make the most of these gardens of life, like octopuses, hagfish, and large crabs, visiting the pools opportunistically to feed on the mussel beds. But often, these delicate ecosystems are at risk of collapse. In some cases, the fragile perimeter walls of the lakes crumble, whelming the mussel beds with toxic brine that leaves behind a boneyard of shells. Brine pools represent a hidden world of fascinating ecology in the depths of the ocean. They are islands of abundance, isolated from one another by the barren abyssal plain, and home to crowded congregations of life interacting and coexisting in a bizarre landscape. In many of the ecosystems found in the deep sea, from whaleful communities to scalding hydrothermal vents and toxic brine pools, there is a pattern of life thriving in very close proximity to death. Whether organisms are deriving nutrients from sunken corpses that give life to the barren abyssal plain for decades, or somehow finding a way to exist in the fine gradient between an energy-giving death trap and the lifeless sea floor, the richly diverse creatures of the deep are specialized to survive in a realm once thought to be devoid of life altogether. And since their discovery, brine pools have represented a new frontier for research and exploration down in the ocean depths. This portion of the video is sponsored by NordVPN. Just like how creatures of the deep have adapted their lifestyles to evade predators, online browsing is evolving too. By connecting to any one of over 5,100 servers in 60 countries, you can protect your identity and data online with NordVPN in just one click. And just like how autotomy in some squid allows them to eject their tentacles when threatened, NordVPN has an automatic kill switch for extra security. If your VPN connection accidentally drops, it temporarily blocks the device from accessing the web. In addition, NordVPN is offering Natural World Facts viewers an exclusive deal. Simply visit nordvpn.com/naturalworldfacts or use the coupon code naturalworldfacts to access this exclusive deal.